Hello dear friends, welcome to the lecture of geometry. We are studying the plane. In the last lecture we have seen how to determine equation of a plane under certain given conditions. In this lecture we are going to study two sides of a plane and then we will study perpendicular distance of a point from a plane. But before starting this, there is one correction in lecture number 2 that is suggested by Supriya Pandit, and that is on example on transformation to normal form. There we have solved one problem in which I have written root of summation a square, that is the root of a square plus b square plus c square, which is this quantity. And by mistake I have written this quantity as root 5, but it must be 9. See, and therefore this is a correction to be made in that lecture, that is root 9, or which is equal to 3. So please do this correction in that lecture number 2. So it is simple but important. And if you have any doubts or any questions or any suggestions, that will be always welcome. You can send it through message or through comment, or you can send it to my mail address. The mail address is I have put in the YouTube channel. So thank you. Now we will come to the content of this lecture, that is two sides of a plane. And see, if we consider a plane, then that plane will have two sides. So this board is a plane, and its two sides will be the front side and the back side of the board. And if you consider, or otherwise if you have this as a plane, then we say that 2 points are on the same side of the plane if the 2 points lie either on this side or both are on this side. And here the 2 points A and B lie on the same side. So we may say, suppose this is A and this is B. So they are on the same side. Both may be on this side also. And that is the first case. And what is the meaning of different sides? See, if you see the same plane, and the 2 points will be on different side. If one point is on this side and another point is on the other side, or vice versa. This can B may be here and A may be there. And here also AB will be on this side, or AB both will be on this side. That is the meaning of same side of plane and different side of planes. The 2 points will be on same side or different sides. And we want to get a condition that when the 2 points will be on the same side or when they will be on the different side. And that is stated by the plane is in general form ax plus by plus cz plus d is equal to 0. And that the points will be on same side as if the expression, these two expressions are of the same sign or of different sign. And what are the expressions? We have to put these coordinates on this equation of the plane, and that becomes ax1 plus by1 plus cz1 plus d. That is the expression, first expression. And second expression is put the coordinates of b, or substitute these coordinates in this equation of plane, and that gives the second expression. If these two expressions are of the same sign means positive or negative. Both are positive or both are negative, then the point will be on the same, both the points will be on the same side of the plane. See, and if they are of different signs, means one is positive, other is negative, or vice versa, then the 2 points will be on two different sides of a plane. That is the meaning of this result. Now we shall prove the result. What we will suppose first is, suppose the line, or let the line AB intersect the plane. Intersect the plane in point P, or at point P, at the point P. Now the point of intersection, if you see this, then that will be here. This is the P, point of intersection. And here AB intersect the plane, but this will be external point. So this is AB line, and AB line, if you extend this, then the point will be, say, P here. So here the line AB intersects the plane, or the segment AB intersects the plane in an external point, external division, and here the division will be internal. So thus we have supposed let the line AB intersects the plane at point P, and let P intersects AB, or P divides AB, we can say. AB in the ratio. In the ratio R to 1, and that means this is R and this is 1. AP to PB is R to 1. These are the ratios. So and we know if the points A and B will be on the same side if the division is external, and the points will be on different side if the division is internal. So therefore the points A and B will be on the same side, on the same side, same or different side. You can write both together, same or different sides of the plane according as P divides AB. For the same side it is externally or internally. That is, so P here it is external, here it is internal. That is according as R is, and we see here the same side means the division is external, and different side means the division is internal. And when the division is external, then R is negative, the ratio is negative. So the ratio R to 1 will, that means R is negative. 1 is we have taken positive, so then that is according as R is negative or positive. So this we should note first to get this result. The two types of divisions here, external and internal. And when the division is external, then R is negative, and when the division is internal, R is positive. So R is negative or positive. Now we can use section formula to obtain the coordinates of P. By section formula, the coordinates of P will be coordinates of P are, P is equal to, now see here the coordinates of A and B are there, and the division is R to 1. So we will write according to this. So that will be Rx2 plus 1 into x1, x coordinate, divided by R plus 1. And next will be Rx2, y coordinate of B, and plus 1 into y coordinate of A, that is y1. Similar to this, ry2 plus 1 y1 divided by R plus 1. And next rz2 plus 1 z1 divided by R plus 1. So these are the coordinates of P. Now this point P lies on the plane. In both the cases, P is a point on the plane. We have written here, intersects the plane at point P. So therefore P lies on the plane. What is the equation of the plane? The equation of the plane is ax plus by plus cz is equal to 0. Now the point P lie on the plane. So I shall write here as now the point P. Now P lie on the plane. On the plane. So what is the equation of the plane? The equation of the plane is ax plus b into y plus c into z plus d is equal to 0. So this point lie on this plane means the coordinates of this point P must satisfy this equation, and therefore that will give as so this implies A into x coordinate of P, that is rx2 plus x1 divided by r plus 1 plus B into ry2 plus y1 divided by r plus 1. We are putting the coordinates on this equation, and C into rz2 plus z1 divided by r plus 1 plus d is equal to 0. And certain calculations we will do to simplify this. Multiply throughout by r plus 1. So this r plus 1 cancels and d gets multiplied by r plus 1. So that implies A into rx2 plus x1 plus etc. And this d is multiplied by r plus 1 and is equal to 0, the right side. And thus this further implies we take r common and we collect the terms. Here it is a into x2. If we take r common, then that will be a into x2 plus b into y2 plus c into z2, and remaining terms plus d is there. And remaining terms we should write in the second bracket plus remaining terms will be ax1, a into x1 etc. plus b into y1 plus c into z1 and plus d is equal to 0. From this we shall get the value of r, and this implies r is equal to. So r is equal to. We shift this term on that side and that will be negative. So negative sign will be there. And then divide by this bracket. So it is a x1 plus b y1 plus c into z1 plus d divided by. And this term is transferred on that side. That will be a x2 plus b into y2 plus c into z2 plus d. So this is the expression for r. Now that r is negative or positive, that we will decide the same side or different side, that we have mentioned earlier. So r is negative. When r will be negative, if these two expressions will have the same sign, then this quantity becomes positive and this is a separate negative sign. So finally the sign of r will be negative if these two have the same sign. And when r will be positive, if these are of opposite sign, then that will be negative. This quantity in, or you may say this quantity in bracket is negative, then that r becomes positive. Negative of negative is positive. When this quantity in bracket will be negative if these two are of different signs. So that means r is negative. So if these two expressions ax1 plus b etc. And these two expressions are positive, and thus r is negative means these 2 points will lie on the same side because the division is external. So thus this is the result. That means if these two are of the same sign, then the points are on the same side. And if these two expressions, if these are the same here, these two expressions are of different signs, then the points are on the different sides. So this implies thus, if r is negative, This shows that R is negative or positive. According as these two expressions. And only the left side, and it's not equation, it is expression, the numerator, and have the same or different signs. And this proves the result. So earlier we have written R is negative means same side, and R is positive means different side. See this thing, and thus this proves the result. If they have the same sign, then the points lie on the same side, and they have the different sign, the points lie on the different sides. So this proves the result. Now we will have a simple example to use this result. So that example we can consider at any example at random. See example, find whether the points, and suppose A is -1, 0, 2, and B is any points we may consider 1, 2, -1, lie on the same or different sides of the plane. The plane may be taken as x plus 2y minus z plus 5 is equal to 0. Any random example we have considered, we will check this. Now what we have to check? Only the two expressions, this one, a x1 plus etc. That means put the coordinates of A over this left side expression and coordinates of B over this left side expression of the plane, and check the sign only. So here we will have, so solution for this is simple. So this is only for information. We have drawn the figure. Now we are writing solution of this problem here. So for this point we can directly check. We have put these points for A. The sign is, so x is -1 plus 2 into y is 0 minus z means 2 plus 5. And what is this expression? So you see this will be -1 minus 2 minus 3 plus 5, and that is 2. And what about the second expression? We have obtained actually ax1 plus this expression ax1 plus by1 plus cz1, putting the first coordinates on this expression of the plane. Now second, we should find out what is the ax2 plus by2 plus cz2 etc. So put these coordinates on this expression, and that gives x is again 1, it is 1 plus 2 into 2, y is 2, and z is -1 plus 5 is there, plus d is there. And what is the sign of this? We will check. That is, see, it is 1 plus 4, 5 plus 5, that is 10 plus 1, that is 11. And see, this is positive, this is positive. So they have the same sign, and therefore the points will lie on the same side. Yes. So this therefore the two expressions have the same sign, and therefore the 2 points lie on the same side. Of the plane. So this completes the result. You should note that the case is of this type, and here AB are on this side or both are on this side. We have shown only one case. It may be either on one side. So in this way we can use the result to decide whether the points lie on the same side or different sides of a plane. Now we will consider the next result as distance, perpendicular distance of point and plane. This is perpendicular distance of a point, perpendicular distance of a point from a plane. And the result here is, we want to find this result or a formula for this. The perpendicular distance of the point. Now we are fixing the point of the point, say the point may be taken as P, of the point P, x1, y1, z1 from the plane. We are fixing the plane also from the plane AX. Instead of general, we should write it as L into x plus m into y plus n into z is equal to P. This is the distance, perpendicular distance of this point from this plane. So the result is actually to find this, or we may say from the plane is and that will be absolute difference L x1 plus m y1 plus n z1 minus P. This is the perpendicular distance that we want to show. Now the proof for this result. See, first we will see what is the meaning of perpendicular distance of point and the plane, that we will see. Suppose here this is a plane. This is the plane that is given, and here is a point P, and we want to find the perpendicular distance of this point and this plane. So that will be, obviously this is the perpendicular distance of the point from the plane, and for that purpose we will consider, see, or suppose the point is here, and we will consider a plane passing through this point P, which is parallel to this plane, and that will be of this type. First, we may first draw the equation of draw the figure for plane. These two planes are perpendicular to each other, parallel to each other. So these are parallel planes. Now, and suppose this is a point P here, or anywhere we can take the point P. What we are going to do is we consider perpendicular from origin to both the planes, and suppose origin is here. Now it is not necessary that origin is here, it may be here, and we can extend the planes here. The two planes are parallel, we have to draw perpendicular from the origin to the plane, or the figure, whole figure can be rotated, and therefore I shall take the origin here at this place. This is origin, and I will draw perpendicular from this to the origin. Suppose this is the origin, and this can be shown like this. So this is the, or otherwise this may be taken as broken line. This point is, we suppose this is K, and this point we suppose as K dash, and OK K dash is the perpendicular from origin to the plane that we are going to consider. And further we want to find the perpendicular distance from this point on this plane. So let that be, say, this distance, which is PL. This is perpendicular. PL on this, and the P point given as x1, y1, z1. This is the point. Now we will prove the result. First we write the equation of this plane passing through point x1, y1, z1 and parallel to this plane. So this is our given plane. This is the plane Lx plus My plus Nz is equal to P. This is the plane. And we write the equation of this plane first, passing through the point x1, y1, z1 and parallel to the plane. So equation of a plane or we may consider equation of the plane parallel to the given plane. And passing through or parallel to the given plane is. Now what is the equation of a parallel plane? We have seen earlier in the system of planes. What they differ, the normal line is the same for both the planes and therefore LMN will remain the same. This equation is given in normal form, not general form, so that we should note. And therefore what is the change in the equation of parallel plane? Only the constant will be different. That P, instead of P, we may consider it as P1. So is Lx plus My plus Nz is equal to P1. And if this plane passes through the point x1, y1, z1, so if the point or if this plane passes through P, then it must satisfy the equation of the plane. Then what we will have? L into x1, then L into x1 plus m into y1 plus n into z1 is equal to P1. So this result we have. Now we will consider this perpendicular. Let OK K dash be the perpendicular from the origin O to the planes, meeting them at K and K dash. So thus what we will have is this is P, means length of perpendicular. OK dash is P, and this plane we have written as this one, Lx plus My plus Nz is equal to P1. So and therefore OK will be P1. So then OK dash is equal to P and OK is equal to P1. So this K and K dash are only the notations. Here this may be written as K dash, this may be written as K. This plane will be above or this plane will be below, or the position will be interchanged. So but what we are going to do is we want to find this distance from point P and this plane. So we have drawn the origin is here. If origin is there, then this will be the perpendicular. So you have to understand these different situations or positions. So this is OK, O, and that is this plane. This is the plane. So it is P1 distance, and O to K dash is P distance. So this we have. And now let PL be perpendicular from P on the plane, given plane. Let PL be the perpendicular from P on the given plane. Given plane means this plane. Then, so what we will have, PL distance, then PL is equal to, this will be, see, OK dash minus OK. this length O to K dash minus O to K, or that is we will write in absolute difference OK dash minus OK, because if this position is interchanged, then there will be the change in sign, but the length is always positive, so that's why we will take the absolute value. And that is, what is OK dash? OK dash is P, and what is P? P is this distance. See, OK dash we have as P, and but you see here OK dash is P, and OK is P1, that is right. So OK dash, that will be P minus, and what is OK? OK is P1. So P1 is having this expression. So this we will use this expression for P1, and that is that will be P minus P1, OK dash minus OK, that is P minus P1 actually. And what is the P is we will keep P as it is, and then what we will consider is P1 is this expression, or this may be written as mod of absolute value of P minus P1 is same as absolute value of P1 minus P, or that can also be written as, that's why we are writing absolute value. This may be, if it is say 2 minus 3, then we should it is same as 3 minus 2. Mod of see, mod of 3 minus 2 is same as mod of 2 minus 3. It is 1 here, and here it is the absolute value of minus 1 is again 1. So distance is positive, and therefore I shall write this step here, that is mod of equal to P1 minus P. And what is P1? P1 is this value, you see, Lx1 plus My1 plus Nz1 minus, this is P1, and minus P we will keep as it is. So this is what we wanted to prove. The distance is absolute value of Lx1 plus My1 plus Nz1 minus P, and this proves the result. So thus we have obtained the formula for perpendicular distance of a point and a plane when the equation of plane is in normal form. And there is a result which will be obtained for the general equation of plane. In place of this equation is general, that means A into x plus b into y plus c into z plus d is equal to 0. Then what is the distance of this plane from the point x1, y1, z1? That result is also there. We will see that result in our next lecture. Thank you.